Hello guys, welcome back to Coding with Bobby, and today we're solving the biweekly contest 128, and this is our third question where we're given a undirected graph of n nodes. So we're given these edges. Edges means there's an edge from 0 to 1 and with a weight of 2, or the time taken from 0 to 1 is 2, and from 1 to 2 it's 1, and the time from 0 to 2 it's 4. And now there's an interesting fact to it that disappear means 115, that this 0th node will disappear after 1 unit of time, this will disappear after 1 unit of time, and this will disappear after 5 units of time. So we need to find the minimum distance or the minimum units of time required to reach every node from node 0. And if we can't reach a node, maybe it has disappeared already, then that means the -1 will be the answer, right? So for 0, we are there on the 0th time. So for 0 it is 0. Now for the first node, when I go from 0 to 1, it will take me 2 time units, but on the first time unit only it has disappeared, so I can never reach 1, so it is -1. And for the second node, I can reach from 0 to 2 in 4 units of time, and it will disappear after 5th unit of time, so I can reach there in 4 units of time. So this question seems to be a clear example of Dijkstra. We can use priority queue, and we can just add this disappear condition. If before the time already that disappear time of that node has already reached before the current time, then that means we can't reach that node. So we'll just approach it with the Dijkstra's theorem, and let's just solve it. We'll take one 3D vector or 2D vector of parent int comma int we'll take, and we'll just name it adjacent list and of n. We are already given n is the number of nodes. Yeah, fine. So now what we can do, there's some issue. 1 second, I'll just reload it. Yeah, so we'll just loop over all the edges for const auto, and edge will take edges, and we'll take the u from which it is coming, which is going to be edge of 0, then v, which is going to be edge of 1, and then w, which is our weight. Actually this is the time. And now what we'll do, we'll just take adjacent list and we'll take u and dot push back, and now we'll push to it v comma w, like that. Now we'll take for the v, because it is undirected. If it is had been directed, then we'll only take from u to v, but in this case we also need to take from v to u, like that. And now we'll take a priority queue. Now the priority queue will be a pair of int comma int, which will store my time and node, the time it has taken to reach that node. Int comma int, and then vector pair int comma int. I'll just maximize it, and we'll also take greater, because we need to take it in ascending order so that the node which we can reach first or at the earliest time should be popped up first, and greater, and we'll also take, yeah, like that, pq. And now what we can do is we can take one resultant vector int res and comma -1, and we'll also take visited, which is gonna be our false. Yeah, because currently all the nodes are unvisited, and we can push to it 0, 0. Now this 0, 0 means time and node, so the time taken to reach the node 0 is 0, like that. Now what we'll do, we'll just loop over till our priority queue is not empty, and we'll get the first one, auto time comma node. It's gonna be, you can also take it like dot first, auto x dot first, like that, pq dot top, and we'll pop up from here. And now the interesting thing, we need to check if visited node, if the node is already visited, or the current time is greater than equal to disappear time of that node, then we can just continue. See, if the current time is supposed 2 and the disappear time is 1, right? So we have already got that node disappeared, so we'll just continue. We can never reach that node. And now we'll just set visited u equal to true, and we'll also do resultant. We'll update the resultant, and it's not u. Okay, we'll just name it to u instead of node. U and v seems to be nice. Yeah. Now we can just check if resu is equal to -1, that it has not been set until now. We can just set it to time, otherwise we'll just do it minimum of resu and time, like that. Yeah, 1 second. Yeah, so now what we need to do, now we are on one node. Now we need to traverse all the nodes linked to that node. So what we'll do, for const auto, and we can take all the adjacent nodes of it. And this will be this, and now this adj will contain the v, the nodes to which it is going, and it will also contain the wait or the time it is taking. So v is going to be adj.first, and time taken will be w, which is going to be adj.second, like that. And now we'll check if not visited v, and if visited we'll check if it is already visited, or the time, again the same condition, if time is greater than disappear of that v. Now instead of time, what we need to set is time plus w, because now the new time will become the current time plus the time taken to reach that node. That means if this is the case, if already we'll exceed the disappear time, then we can just continue, right? And if it doesn't, then we can just push pq.push, and we'll do time plus w and v, like that, and we can just return result. Let's just try to run it. We've got some error into it. Okay, yeah, that was a very silly mistake on my part. pq.top, and again some syntax error. Okay, there are still so many of these syntax errors on this one. resu is equal to -1, that means we're gonna take time, otherwise. Okay, there's one more that's missing. Boom, works fine. We'll just submit it. Yeah, works fine, and it beats 100% of the users. So the main idea was to use the Dijkstra's algorithm here with just this one more condition to see if the current time has already exceeded the disappear time of that node. And we are making use of priority queue so that we can always grab the node which we can reach the earliest. So that's it for this video. Thank you.